What does it really mean for an AI to think? Today, we're diving deep into Interview.net memory management. Every .NET developer faces this interview question. It separates commodity engineers from platform architects. In a cloud-native, cost-conscious world, memory control is strategic leverage. Mastery signals seniority. But here's where it gets interesting. The managed heap is lying to you. Automatic collection masks lethal behaviors, allocation storms, silent fragmentation, unpredictable pauses. At scale, Gen 0 collections hide unsustainable throughput loss. Existing trust the GC practice fails under load. So what's the real problem? Let's talk about root cause, the abstraction gap. Developers treat memory as infinite. Short-lived allocations pile up. Large object heap fragments. Finalizers queue unseen. The cost emerges only in production latency spikes, crashes, ballooning infrastructure spend. This raises a critical question, breakthrough, from garbage collection to memory ownership. Modern .NET delivers deterministic control. SpanT, memory. Stackalloc, ArrayPoolT shift the paradigm, allocate less, reuse aggressively. Own the lifecycle. The runtime is no longer a black box. Now let's zoom in on system model, CLR memory topology. Virtual memory managed heap segments, generation 0, 1, 2 plus LOH plus POH, background GC engine, workstation versus server modes, and region-based allocation operate as a configurable pipeline. Here's something most people overlook: component architecture, thread local allocation context, GC mark sweep compact phases, finalization queue, and F reachable list. Pinned object handles bridge to native interop. Each component is a tuning point. Think about this for a second. Workflow. Allocation collection reclaim. Bump pointer alloc generation 0, threshold breach. Ephemeral GC triggers survivors promote compaction, relocates segments recycled. This cycle is the heartbeat of application throughput. And this is where things get complex. Failure patterns, the silent killers. Boxing value types. String concatenation loops. Captured delegate closures. Static event leaks. Midlife object pinning. Each pattern steals throughput and increases GC pressure invisibly. But here's where it gets interesting. Precision toolkit. Zero allocation primitives. Span, Radel span, memory pool, memory marshal. Unsafe, refstruct, dispose patterns. These APIs bypass heap allocation entirely for hot paths. So what's the real problem? Let's talk about impact. Memory as a business multiplier. A memory-disciplined codebase delivers 90% fewer Gen 2 collections, single-digit millisecond tail latencies, 40% cloud compute cost reduction. Memory performance is now a direct revenue protection lever. This raises a critical question: future state, ahead of time, and native memory. Native AOT compiles directly to machine code, eliminating JIT overhead. UTF-8 pipelines, iBufferWriter.NOT, and non-allocating I/O rewrite the rules. Ahead-of-time layout control is the next frontier. Now, let's zoom in on the interview. System-level thinking required. The test is not what is Debisis. It's how does the heap segment manager interact with GC regions under sustained load. Demonstrate you see the entire machine, not just the syntax.